Hello, so I'm going to give you a quick 15 to 20 minute talk on all about applying to engineering as a university course. So before I get kind of into the nitty gritties of what it's like to study engineering at university, I thought I'd give a quick introduction to myself. So my name is Ellie and I work as a UK student recruitment assistant within the University of Sheffield schools team. I'm also a recent graduate from the University of Sheffield as well, and I really enjoyed my time here. I'm originally from the Wirral, which is in the northwest of England, so I came about 2.5 hours to attend Sheffield University. And when I was in sixth form, I studied A levels in biology, chemistry, maths, and English literature as well. And as I said, I then went on to study at Sheffield, and I studied a 4-year course in chemical engineering. So this was the 4-year integrated master's programme. So the full degree title was MEng Chemical Engineering with Biotechnology, which is a bit of a long degree title, but I really enjoyed my course and I was really interested in that extra biotechnology aspect. So I was really keen to kind of continue learning about that at university and not just straight chemical engineering. But first of all, we're going to start with the basics. So what is engineering and why might you want to study it at university? So engineering is all about the application of science and maths to solve real world problems. So literally the problems that are facing the world today, engineers are needed to solve them. And I find that engineering is really an interface between all the three sciences and maths. So it's likely it won't have been a subject that you will have studied before at school or sixth form, but you will have studied aspects of it in other subjects such as the sciences and maths and things like that. It's all about applying these maths and science subjects. So I didn't find there was much kind of theoretical work, and that's something that I really enjoyed about engineering. Obviously there is the theory and a lot of theoretical maths and things like that, but it's all about applying it to real world problems, usually on quite a large scale as well, and particularly that was relevant for my course, chemical engineering. So I found for me that it was the perfect combination of all three of my kind of favourite subjects at school, as well as maths. So it kind of just ticked all my boxes, and that's what drew me to engineering. But it's not always about, your typical engineering jobs that might be working in a power plant or building a bridge or fixing a car or something like that. As an engineer, you can do absolutely anything. You could design a new roller coaster, whether that's the track or maybe some of the cars to go on the roller coaster. You could invent a new food product. You could create artificial body parts. You could even minimise the effects of climate change or maybe even solve climate change. So it's a really, really broad discipline, and you'll focus kind of more or less on certain areas of engineering depending on the specific type of engineering you go on to study. Or you could go on to study general engineering and you'll get to kind of pick and choose the areas of these that interest you the most. But no matter which strand of engineering you might be applying for, you'll be getting to work on some really cool and cutting edge projects as well. So what is chemical engineering? So this is the subject that I studied. And chemical engineering is all about converting raw materials into useful products. So the way I always describe it to my friends and family is if you were at home and you came up with the best chocolate bar ever. You made a chocolate bar in your kitchen at home and you thought, wow, this is delicious. I want to go and sell this to the world. I want to go and sell this on a massive scale. And you would need a chemical engineer to get your raw materials, that might be, your butter, your sugar, your chocolate, into useful products, chocolate bar, on a large scale. So rather than you just making a single chocolate bar in your kitchen, how can you go on to make that millions and millions of chocolate bars and be producing them very cheaply, very quickly, very safely, and distribute them to the entire world? So that kind of leads me on to the second point, that chemical engineering is typically working on a large scale. So we might be dealing with reactors or large tanks that might be kind of thousands of litres in volume, so really, really, really big. And that differs quite a bit to chemistry and some other science subjects which might be working on more of a bench scale. So a chemist might, come up with a chemical reaction, They might be doing, you know, all the balancing equations and electron transfer and all those kind of things that you learn in A-level chemistry. We don't really touch that. They kind of come to us with, say, you know, a reaction, and we are the ones that then scale it up and make it on a really large scale. So it is quite different, I would say, from studying chemistry at school. Obviously, particularly in your early years of uni, you'll have to do a lot of baseline organic chemistry and math skills and things like that as well. But in the later years, you do find that it becomes quite different. So you're doing things like heat transfer, fluid flow, sizing valves, doing a lot of computer-aided design, drawing power plants and things like that. So it is quite different from other subjects you'll be taught at school. And obviously I can't quite speak for every engineering discipline, but I would probably be confident in saying that, you know, they are quite different from maths, chemistry, physics, biology, and that's what makes them fun, I think, because it combines all different aspects of all of those sciences. And so what career paths are open to me as a chemical engineer? Well, engineers in general are needed in pretty much every single industry you can think of. So that's exciting. But chemical engineers typically could go into sectors like renewable energy, oil and gas, pharmaceuticals, so making medicines, nuclear energy, fast-moving consumer goods, so making products such as food and toiletries. This is an area that I'm actually going into working in fast-moving consumer goods next month, because I'll be going to work for Cadbury's, the chocolate factory. So if you've had me mention chocolate a little bit during this presentation, that will be why. But that's an area that I'm really interested in. And then you've got all the disciplines that are open to all your degree subjects. So there's a really good stat that about 60% of graduate jobs are open to all degree disciplines. And that's probably going to be closer to 100% if you study, you know, a science or an engineering course. You could go on to work in consultancy or banking or law or finance or civil service. All of these areas, you know, studying engineering doesn't close any of these paths to you. It just keeps lots and lots of different doors open. So that was really reassuring for me when I realised that kind of all these different interesting jobs that I thought I might like to go and do in the future, you know, don't discount them, basically. You are really highly employable as an engineer. So some of the skills you'll need to be an engineer, and a bit later in this presentation we'll be talking about applications and personal statements, and you might want to be keeping some of these in mind, because these are the skills that, you know, you either might have some experience of now, or skills that you might be thinking, oh, how can I demonstrate that I have that skill in a personal statement? So as we've mentioned a little bit throughout this presentation, engineering is all about being a problem solver. So if someone comes to you with, oh, this piece of machinery isn't working, this process isn't working, this product we're making is too expensive, we need to make it cheaper, an engineer needs to sit down and think, right, how can we fix that? And often that will involve quite a bit of creativity. You know, you've got to consider lots of different options, think outside the box a little bit, which is a skill that I don't think a lot of people know that engineers need to have, is being creative. Attention to detail we've mentioned, so on a kind of technical knowledge, you know, you need to be highly numerate and be quite practical as well. Team player, I think, is a massive one, because, well, you can see in the background here, this is our Formula One racing team, and they will have been able to work together as a team to produce a racing car. But typically engineers work in teams, and often, you know, a team of colleagues you're in a company with, you might not know these people, you might be put together on a project for the first time, and you've got to get on with other people, you've got to be able to communicate together and work together on coming up with the best solution. And you'll get a lot of exposure to this as an engineering student. You'll have plenty of group projects that you'll work on together, group presentations. There's very few times you'll kind of be working completely by yourself, so it's definitely a key skill as an engineer. Technical skills we've mentioned, you know, employers will be looking for you to be highly technical, receive good grades in all your different modules, and economically focused as well. This is something that I think also gets forgotten a little bit. And engineering is also about doing things correctly and safely, but it's also about doing things the cheapest that they can be done. That's something that I notice more and more in my degree, is that companies, you know, will look are not only looking to improve their processes and to make new things, but they're always looking to do things cheaper and save more money. So you've got to have a good kind of sense of economics on your head, and you'll be taught this again as a university student, so don't kind of panic about it too much. But it's just good to have good commercial awareness as well, I would say. So engineering at Sheffield, these are all our different engineering departments. So we have a really large engineering faculty, and we have engineering that you'll probably be familiar with, maybe like mechanical and civil. But we also have some bit more obscure ones, such as automatic control and systems engineering, which is quite focused on robotics. We also have aerospace, bioengineering, computer science, material science and engineering, which is a really popular department at Sheffield. There's plenty of different options out there. And as I said, you can study general engineering as well, which gives you lots of flexibility, and you can study lots of different areas of engineering, and then you specialise in your later years as well. And I thought I would give you a bit of a week in the life as an engineering student, because before you get to uni, it can be quite hard to picture what a typical week might look like. So first thing I'll say, that as an engineering student, you typically have a lot of contact hours compared to other university students. So you might have maybe 20 hours a week of contact hours. And by contact hours, I mean things like lectures, seminars, tutorials, any time where you're taught by someone at the university. And then in addition to that, you'll have independent study hours where you might need to go and work on a project, do some revision, do some problem classes, work on a group presentation together, lots of different things. One nice thing is that all university students at Sheffield have their Wednesday afternoons off as well, and this is time where you can join societies, do sport, do volunteering, so it doesn't have to be, every single day, doesn't have to be completely course focused. It's really nice to get to experience the wider university life as well. So I'll talk you through a couple of different ways you might be taught as an engineer. So on Monday mornings, you might have a lecture in the Diamond, which is our engineering building I was talking about. And this might be around 100 students, so there's quite a lot of you. Sometimes it can be up to 200 or 300 students. And there's not that much interaction between you and the lecturer. It's mainly you kind of sat listening to a PowerPoint or some kind of presentation, and you taking notes on paper or a laptop, and then you'll go away, consolidate those notes, fill in the gaps, maybe do some quiz questions for yourself and things like that. And if you don't understand anything, you might do a bit of reading, you might go and ask a course mate, go and see your lecturer. You also might have computer classes, which is nice because it's easy to just kind of put up your hand and someone come around and help you if you're stuck. You might be learning a new piece of software, maybe you'll be learning to code, maybe you'll be doing some CAD drawings. It just depends on the module really. And then you might have labs. So as a chemical engineer, I had a lot of labs kind of working with chemicals, but also, things like fluid dynamics, heat transfer, fluid flow, particle physics, lots of different things like that. And these are a great way to get some hands-on experience using equipment that you would use in industry, so it's all completely industry standard. And I found this was a nice way to make friends as well, because typically you're in smaller groups, so it was a nice way to get chatting to other students. And another nice thing about first year is that you might also have a maths problem class, and this is the most similar thing I found to studying at school. There might be about 30 of you in a room, and the lecturer would go through a new mathematical technique, and then they might give you a list of problems for you to work through. And if you're stuck, you need a bit of help, again, you just stick up your hand and a lecturer would come round, sit next to you, and kind of help you out. So that was really nice to get everyone up to the same standard, because, some people have done further maths. I didn't do further maths. Some people have done physics, some people haven't. I didn't do physics A-level. People are coming from different countries with different qualifications. Some people have done a gap year. Some people might have been out of education for decades. So it's just really nice that everyone gets those core math skills. So when you go on to do the harder things in later years, everyone's up to speed. So I really enjoyed that. And some extra things you can get involved in as an engineer. So I've mentioned things like our Formula One racing team. We also have a team that designs railways and trains. We have Engineers Without Borders that works to solve some of the kind of world's key problems, particularly in third world countries. And these are multidisciplinary engineering teams. So you might have a chemical engineer in the team, a mechanical, an electrical, etc., etc. And you'll work together on a brief, and usually you'll see your solution implemented wherever the problem may be arising. So that's really fun. Some other things that I got involved in was research. So as a Russell Group university, you can get thrown in right into research. I did my 4th year research project in collaboration with Nestle, so the company that make Kit Kats, and Nescafé coffee, and I got to research all about biodegradable plastics and how they can store their coffee powder in these plastics. So again, it's this really cutting edge, up-to-date research that's really relevant. I also did some summer placements, one of them being at the university with the Sheffield Undergraduate Research Experience, where I worked in a biotechnology lab looking at dsRNA, and I got paid to do that research placement, which is quite nice as well. And in my 3rd year, my version of a dissertation, which is basically kind of your big major final project, ours was called a design project. And for this, you work in a team. So you can see me and my team in the background here. We didn't really know each other that well, but we got on really well. We worked really well and strong together as a team. And our project was to design a bioethanol plant. So we had to design the plant right from scratch, right from kind of the whole chemical process, safety, the economics, where we would put the plant in the country, and produce a big report, presentations, drawings, all that kind of thing. So it was definitely challenging, but also really rewarding when you come out the other side with a good mark. So definitely take advantage of all these different opportunities you can get involved in. And finally, just to finish off, I thought I'd give you a couple of different tips that I think you should be bearing in mind for things like UCAS applications. So on your UCAS application, you can apply for up to 5 courses, and I would recommend applying for courses with a wide range of entry requirements. So have some aspirational, some realistic, some backup options in there. And engineering courses, the entry requirements can vary quite wildly, so make sure you're checking them out carefully. Don't discount courses, because at first I thought, I can't do engineering because I didn't do physics at A-level. But when I actually looked into it a bit more detail, hardly any universities required me to have physics for chemical engineering, and I was fine with my chemistry and maths A-level. So definitely look closely at all the websites and make sure you know what the entry requirements are for all of your 5 choices. Think closely about the MEng and the BEng as well. So an MEng stands for a Masters of Engineering, whereas a BEng stands for a Bachelor's of Engineering. And the Masters of Engineering is usually a 4-year integrated master's programme, whereas the BEng is only a 3-year programme. The advantage of that extra 4th year is that you get to do a research project, you get to learn your subject in a lot more depth, you get a lot of independent study skills, and if you want to work in industry, or if you want to maybe do a PhD or work in research, you are going to need that master's year. I applied for the master's year, kind of unsure which one I would rather go for, but I just thought, I'll just apply for the master's year and I'll just decide later. And I would definitely recommend that option. It's much easier to switch from the master's year, from the MEng to the BEng, than it is the other way around. Although it's not impossible, you can apply for the 3-year course and then switch to the master's course when you get there. But usually you have to meet certain grade requirements to do that. So if you're not sure if you want to do the 3 or the 4 year, I would say apply for the 4 year, and you can always change off it if you want to. It usually just requires you filling out a form and handing it in to the university. It's really simple. Think about if doing a year in industry that we've talked about, or a year abroad is important to you. Not all universities offer these, so make sure that the courses you're applying to do, if this is something that's quite important to you. You can also usually find out the different study abroad destinations for your course if you're interested in that. So for Sheffield, for example, you can Google Sheffield Uni, engineering, study abroad destinations, and it will give you a list of all the different universities you can study at. You can also go into the course web pages, and it will tell you where people from your course, where they did their year in industry, what they enjoyed about it, any tips they have for securing a year in industry. So definitely check them out. And also, I would recommend looking closely at the different modules offered at different universities. You can find these on the course web pages, and these will show you the exact things that you would study at during that course. And every university has different specialisms. There's no national curriculum, every university can teach the course exactly how it wants to. So me studying Chem Eng at Sheffield could have been really different to me studying it at Leeds or Manchester. So make sure you're applying to the course that's right for you. And finally, a little bit on the personal statement. So I'm sure you know by now what a personal statement is, but a couple of extra tips from me for if you're applying for engineering. So at Sheffield, we say keep it subject focused. About 75% of your personal statement should be focused on your course and why you want to do that course, what in the past has led you to wanting to do that course. And then about 25% of it should be extracurricular focused. So what else do you do in your spare time that has made you a well-rounded person, that's going to make you a good university student? What kind of skills and things like that have you gained from those extracurricular activities? And also keep it evidence-based, so think like an admissions tutor. If you say, I'm a good team player, therefore I will do well in engineering, that might be true, but what an admissions tutor will be thinking is, well, what teams have you been in the past? What evidence have you got that you work well in a team? And how will that benefit you in engineering? Have you read or seen or heard about any recent engineering breakthroughs that really interest you? Feel free to mention them, say why they interested you. Did it lead you to applying for this course because you read something in a newspaper and you went away and did a bit more research into the topic and thought, yep, I really want to study that for 3 years? And don't be afraid to show your thought about potential careers. If you don't know what you want to do, which is the position that I was in, don't worry about it. But if you do know, feel free to name drop it, and say how the course you're applying for is going to help you get to that end career path as well. But above all, demonstrate your enthusiasm. Make sure all the enthusiasm and why you're really, really interested in the course is coming across to an admissions tutor, because admissions tutors want to take on students that they genuinely think will make a real impact on the course and will get stuck into university life and will really enjoy their 3 or 4 years at university. So that's definitely my key tip to end this presentation on. But that brings us to the end of the presentation. Thank you for listening. Feel free to check out all our engineering web pages. We have a lot of subject taster days as well, where you can try out different engineering courses, see which one is right for you. And these are all taught by our lecturers, so literally the lecturers that would be teaching you as a university student. So it's a really good insight. Check out our open days as well, where you get to speak to current students, receive presentations from lecturers again. And we also have a chat to us service, where you can speak to current university students online. So you could speak to a current, say, mechanical engineering student and ask them all about their course and why they chose it, and just pick their brains basically. So definitely check out all the different things on our website. But thank you all for listening, and good luck with all your applications, and hopefully this has given you a short insight into what studying engineering is like.